Okay, this is the video solutions for the complex number homework. And in lecture, we went over some ideas that we're going to be using here. Let's recall what we went over. That we're going to use the product rule first of all. That the square root of a product is product of square roots. Okay, we're going to use the product rule. We're also going to use the fact that the square root of -1 we're going to define to be I. So whenever I see the square root of -1, I'm going to replace it with the letter I. I represents what's called an imaginary component. So this is what we're going to use to either simplify or evaluate the radicals that are negative with the square root, meaning what's under my radical, if you notice, is a negative number. Now, we can't take the square root of negatives. In other words, the answers, the solutions here are not real numbers. They're imaginary in an intermediate algebra sense. They're really complex, but we call them imaginary for intermediate algebra. Complex numbers is the real definition for what we're working with here. Nevertheless, let's get started here with this. And the square root of -4 can be written as -1 times 4, where -4 here is described as -1 times 4. Now, this is where we use the product rule. This is going to be the square root of -1 times the square root of 4. And the square root of -1, we see that it's here, gets replaced with I. We can evaluate the square root of 4, and we know that this value here is 2. So we don't write this as I times 2, we actually write it with the number before the letter. 2 times I, or simply just 2I. So this is the answer for the first problem. So this is what we did in lecture, and let's work on these problems for homework. Number 3, square root of -9. We're going to write this as -1 times 9. -9 can be written as -1 times 9. Notice I have a -1. So we get the square root of -1 times the square root of 9. Whenever I see the square root of -1, I replace it with I. The square root of 9 is the value 3. We can write it as I times 3, or 3 times I. It's really actually 3I. We're done. Number 5. The square root of a -36. We notice we have a negative number under our radical. So we're going to write this as -1 times 36. By the product rule, we get -1, square root of -1 times the square root of 36. Square root of -1 we replace with I, and the square root of 36 we know is 6. So we can say that our answer is going to be I times 6, 6 times I, or simply 6I. Number 7, square root of -81. We notice we have a negative value under our square root sign here. So we're going to write this as -1 times 81. And by our product rule, we get -1 times the square root of 81. Notice again, I have this square root of -1, and I'm going to replace it with I. The square root of 81 is 9. So I can write this as I times 9. 9 times I, or really just 9I for short. And we're done. Let's reorganize some things here. Excuse me. Okay. Number 9. The square root of -64. Notice we have a negative number under the radical. We write this as square root of -1 times positive 64. Square root of -1 times the square root of 64. Notice again, square root of -1 gets replaced with I. 64 is the value 8. So I can write this as I times 8, 8 times I, really 8I for short. Number 11, square root of -8. Notice again, we have a negative number under our radical. We write this as -1 times 8. Square root of -1 times the square root of 8. Again, the square root of -1 gets replaced with the letter I. And the square root of 8 can be simplified. So let's simplify the square root of 8. Let's recall that 4 times 2, where 4 is the largest perfect square that goes into 8. By the product rule, we write the square root of 4 times the square root of 2. The square root of 4 is 2. So the square root of 8 gets replaced with 2 times the square root of 2. Altogether, I have I times 2 times the square root of 2. Now remember, I suggest to you to write your answer where I is at the end. And make sure that this I is not under your radical for the square root of 2. This is how we write our answers in complex number form. I'm going to say and remark that intermediate algebra books from high school like to place this I right in the middle. They do that because they kind of don't trust the fact that these high school students are actually going to, put the I outside of the radical, that sometimes they get a little lazy and they put this I under the radical, which is a whole other thing. So this is actually, not what we're saying when we have our final answer being 2 times the square root of 2I. Just make sure your I is outside the radical. If you want to actually write your answer in the intermediate algebra format here, then that's perfectly fine. But the preferred way is to write it as a complex number. So I'm going to remind you guys of that. Number 13 on the homework. You have the square root of -75. And notice again, we have a negative number under our radical under the square root. In the past, we could not give an answer that was a real number. So we're going to have to rewrite the -75 as -1 times 75. Square root of -1 times the square root of 75. Notice again, square root of -1 gets replaced with I. And the square root of 75 can be simplified. So the largest perfect square that goes into 75 is 3. Product rule. Square root of 25 is 5. This is 5 times the square root of 3. Altogether, I have I times 5 times the square root of 3, or simply write this as 5 times the square root of 3 times I. And you're done. Number 15. Square root of negative 24. We have a negative number under our square root sign. We're going to write this as square root negative 1 times 24 square root negative 1 times the square root of 24. Square root of negative 1 is I. Square root of 24 can be simplified. The largest perfect square that goes into 24, I believe, is 4, and it's 6 times 4, where 6 is the quotient. Square root of 4 times the square root of 6, or 2 times the square root of 6. All together, I times 2 times the square root of 6, or simply 2 times the square root of 6, I. Number 17. Square root of negative 12. Notice the value under a radical is negative, so we're going to write this as square root of negative 1 times 12. By the product rule, square root of negative 1, square root of 12. I'm going to replace this square root of negative 1 with I. Square root of 12 can be simplified. We write the square root of 12 as 4 times 3, where 4 is the largest perfect square that goes into 12. 3 is the quotient. Square root of 4 times the square root of 3 gives you 2. Two times that square root of 3. Altogether, I times 2 times the square root of 3, 2 times the square root of 3, I, in complex number form. Number 19. Square root of negative 54. We have a negative number under the radical, so we're going to write this as negative 1 times 54, which is the square root of negative 1 times the square root of 54. Square root of negative 1 is the value I. Square root of 54 can be simplified. Can it be? Let's think. Well, let's think about this. How do we write 54? Let's factor this. 2 times 27 is 54. 3 times 9 is 54. And 3 times 3. Well, it can be simplified. So let's go back. I'm going to write this as the square root of 9 times 6. The largest perfect square that goes into 54 is 9. 6 times 9 is 54. Okay. So we have the square root of 9 times the square root of 6, which is 3 times the square root of 6. Here's what happens. Now I have I times 3 times the square root of 6, or 3 times the square root of 6i. And we're done. Square root of negative 120. Notice I have a negative number under my radical. We're going to write this as square root of negative 1 times 120. We're going to use the product rule. Square root of negative 1 times the square root of 120. Now, the square root of negative 1 here, we replace that with I. Square root of 120 can be simplified. So we're going to have to try to find the largest perfect square that goes into 120. it might be helpful to try to factor 120. So let's see. 120 can be described as 4 times 30. 4 is 2 times 2. 30 is 6 times 5. And then 2 times 3 for 6. We get our primes. So this 120 can be described as 2 to the third power times 3 times 5. Now the largest perfect square, turns out, that goes into 120 is 2 squared. Here's my perfect square, really, which is 4. Now 2 times 3 times 5 is going to be 30. So 4 times 30 here. This number here is 30, and this number here is 4. Okay, 4 times 30. Let's get rid of all this. The largest perfect square that goes into 120 is the value 4. So the square root of 120, 4 times 3, square root of 4, square root of 3 is 2 times the square root of 3. Oh, 30. Let's not make that mistake. Two times the square root of 30. So let's write our answer. I times 2 times the square root of 30 is 2 times the square root of 30, I. That's 21. The square root of negative 6. We have a negative number under the radical, and we write this as the square root of negative 1 times 6. Square root of negative 1 times the square root of 6. Replace the square root of negative 1 with I, and we're going to notice that the square root of 6 here is already simplified. We can't simplify that radical of square root of 6. So, final answer is the square root of 6, I, for 23. 25, square root of negative 2. And we notice a negative 2 is under this radical. It's a negative number. We're going to write this as the square root of negative 1 times 2, and by the product rule, square root of negative 1 times the square root of 2. Square root of negative 1 is I, and the square root of 2 is already simplified. So we can write this answer as the square root of 2 with the I outside the radical. The square root of negative 7. Notice again, negative number under the radical. We write negative 7 as negative 1 times 7, and by the product rule we get negative 1 times the square root of negative 7. Square root of negative 1 is I, and the square root of 7 is actually simplified. So I get the square root of 7 I here, and you're done. 29 is we're going to add and subtract complex numbers, imaginary numbers. This is simply combining like terms. So I can think of this as having 2 apples plus 5 apples, which end up giving me 7 apples. This is what we worked on in class. So notice here, I'm going to put this 2i plus 5i, and that's going to end up giving me 7i. That's the idea behind this, combining like terms. We have 12i minus 5i. Same idea holds. We got 12 apples minus 5 apples, and that's going to give me 7 apples, or 7i. Where the I is considered an apple, not really, it's imaginary. You guys see the point. Now if you wanted to, in class, if you recall, you're really taking the 12 minus 5, you're doing that arithmetic, and you're keeping the label I. And 12 minus 5 is 7, so this is 7i. Either way you want to look at it is fine. (33). 1 plus I minus 8. We're going to combine like terms. The only terms that are like here are going to be the 1 and the -8. The I is another term. Think of it as an apple if you want. Anyway, 1 minus 8 is -7 plus I, and we're done. We cannot combine these two terms. They're not like. They're not the same. 35. 12 minus 3I plus 8. And the terms that are like here are the 12 and the 8. You have a 3I here. That's different. So we're only going to combine the 12 and the 8, and we end up with 20, because 12 plus 8 is 20. Don't forget to bring down the minus 3I, and you're done. 37. 1 minus I plus -3 plus 5I. Now we're adding here two complex numbers. We can get rid of the parentheses and just look at it as 1 minus I plus a -3 plus a 5I. We're going to identify the terms that are like. The 1 and the -3 are like. We got our I and our 5I. Those are like. We're going to combine the like terms. 1 minus 3 is 2. -I plus 5I is plus 4I. If you owe an apple and you have 5 apples, you're going to end up with 4 apples. And you're done. 39. 2 plus I minus a -3 plus I. Now this is a subtraction problem. We see the subtraction sign here. We can't just drop the parentheses. If we remember, we can look at this as 2 plus I. The first set goes away. And this is a -1 now times your -3 plus I. So you're going to have to distribute the -1 here to both terms. You have your 2 plus I minus some minus, or -1 times -3 is +3. -1 times your positive I is -I. You're going to combine like terms. 2 and 3 are like. Plus I minus I, those are like. So if you have an apple and you own an apple, your apples are gone. The only thing we could do is add the 2 with the 3, and that gives you a 5. And you're done. 41. 3 plus 4I plus -3 plus 5I. Your operation here is addition, so we can just drop the parentheses, and we have 3 plus 4I plus a -3 plus a 5I. If we identify the terms that are like, we have 3 and -3. 4I and 5I. Combining our like terms, 3 plus a -3 gives us 0, or it's gone. 4I plus 5I gives us a 9I. And you're done. Notice again, using the distributive property, 4I plus 5I is 4 plus 5, and we keep the label I, which is 9I. 43. -1 plus 2I minus a negative 1 plus 5i. So here we have a subtraction problem. Don't forget to distribute that negative sign to both terms because it's really negative 1 times. The first set of parentheses falls away, and we get negative 1 times negative 1 is positive 1. Negative 1 times positive 5i is negative 5i. Let's identify the terms that are like. Negative 1, positive 1 will add up to 0. Those two terms are like. We have a 2i and a negative 5i. So 2i minus 5i, we can say is 2 minus 5i, which is negative 3i. And you're done. Negative 3 plus 4i plus 2 minus 4i. This is addition. So our parentheses fall away. We're going to combine like terms. Negative 3 plus 2, positive 4i minus 4i. Negative 3 plus 2 is 1, and positive 4i minus 4i is actually 0, so we're simply going to end up with the value of 1 here for 45. Negative 6 minus 4i plus 8 plus 4i. This is addition. Your parentheses falls away. Negative 6 minus 4i plus 8 plus 4i. Let's find the like terms. Negative 6 plus 8, and we have negative 4i plus 4i. So negative 6 plus 8 is positive 2. If I owe 4 apples and I have 4 apples, my apples are gone. It's just a 2. $49. 9 minus I plus 9 minus I. Again, addition. Your parentheses falls away. So we have 9 minus I plus 9 minus I. 9 plus 9 will give us 18. Minus I minus another I is negative 2I. So we get 18 minus 2I. If I owe an apple and I owe another apple, I end up owing 2 apples. $51. 2 minus I minus 2 plus I. This is a subtraction problem. Don't forget to distribute this negative sign. We get 2 minus I minus 2 minus I. 2 minus 2 is going to give us 0. Negative I minus another I gives us negative 2I. If I owe an apple and I owe a second apple, I owe 2 apples.